Now we're going to see a way to relate acid or base concentration to pH, and we can do that both for acids and bases using the same ion, looking at hydrogen ions. This way is this is the definition of pH, and by the way, in science and engineering there are other values that are like pKa. For example, there is actually a POH, but we don't really have a need to look at it. But a pKa is the negative log of the Ka. They all work the same. But anyway, so that's the definition of pH. And then this conversion is using the equilibrium that's always present in an aqueous solution. Here we have a situation with an acid, and we're wanting to find out basically the pH. And the first thing we should notice is that this is a strong acid. That means that when I put it in water, there is no equilibrium. It all breaks apart into its ions. And since there is just one hydrogen here and one there, it's a 1-to-1 ratio between what was HNO3 and what will be hydrogen ions. In other words, to answer this first question, it's basically going to be the same thing. Okay, so there's the answer to that. And remember that when I'm writing H3O plus hydronium, I could just as easily write it like that. Okay, then if we want to do the pH is the negative log of the hydrogen ion concentration. And so you need to be sure you can do this on your calculator. It's not that hard. Just put in your, well, it depends on your calculator. Some of them you put in the log, some of them you put negative, log, and then you put the number. Some of them you put the number in first, then hit the log button, then change the sign. But this is a good time to check and make sure that you can get it to work on your calculator for you. And then as far as sig figs go, remember what I said, that this, anything in front of the decimal point is not a sig fig. And that's because it's kind of like a placeholder to tell you how far away from zero you are. It's like leading zeros, so it doesn't count as a sig fig. So these two sig figs there. And then we might ask, well, does this make sense? Well, there are a couple things we could check. One is that if we put this in scientific notation, this exponent should be within 1 of the pH, and it is. This is 2. So remember that the pH is taking the log of this, which is saying what number is 10 raised to, and it's not quite 3 because this number in front is not a 1. But anyway, so that's one check. The other check you can do is just what you know about acids and bases, and a low pH, this is below 7, is for an acid, and this was an acid.